just a dude with a keyboard, kind of like the dude on the slide. But I like to drink more things than he does. He only drinks one thing. So yeah, so Electron why? Like, why are Electron apps so popular? And it's a fairly straightforward, right? They are cross-platform. So it's cost-effective to write those apps. You create them once, you can ship them to all kinds of platforms. So companies like to make them, right? That's one reason. The other thing is, like, you have fast development for those apps because essentially they are just Chrome processes. So you're just doing web app development most of the time, and you don't have like a costly develop, compile, test lifecycle. You can all do that fairly easily. So development is fast for these apps. You also have rich library support because you're operating in Chrome. You get all of the web libraries, right? Like, if you need to do front-end development, you can load in Bootstrap and you have all of that stuff for free, or you can do some stuff in React if you want. So it's all pretty good. And then additionally, you have Node.js. So you have a really rich ecosystem for Node modules, from everything from trivial operations to also like really complex stuff where Node modules execute like native code and all of that kind of stuff. Yeah, and this is a big one. I think, like, a lot of times if there's some new technology which may be good, it will require developers to kind of skill up and learn new skills. But for Electron applications, because they are like Chrome renderer processes just rendering a website, basically, that means that a lot of web developers who are already very skilled could easily transition without a lot of time to learn those new technologies. So that's made Electron very popular, right? And then I write like Java was popular for similar reasons, but it's kind of BS. All I mean is that Java was popular because it was cross-platform and like a powerful programming language, right? So Electron what? Like, I kind of mentioned this already, but Electron is basically just a Chrome renderer process that renders a web page. That's all it is. And then this process is able to ingest Node modules, so it can do like complex things on host, not just web browser things. And of course, since it's Chrome, it has the benefit of using like HTML5, JS, CSS, right? And so you package basically a web app, and then you can ship it to different operating systems. You don't actually compile, right? I would say, like, you package the app. And then, yeah, Electron who? So Electron is everywhere. I'm sure you're all using Electron apps, no matter where you are or what OS that you're running. These are just some popular examples, right? Like Discord, VS Code, Spotify is a really popular one, right? WhatsApp for desktop is one. These apps are everywhere. This is not an exhaustive list. These are just some popular examples so you understand. One thing I should mention here as well is, like, you see Microsoft Teams is on there, and they, like, a while ago, they said they're no longer using like proper Electron. They're using, because like I said, Electron is like a Chrome renderer process, and they said we're changing to Edge instead of Chrome. But really, when I was doing testing, I didn't see any difference because Edge is based now on Chrome, so it's basically the same thing. How do Electron sessions work? Mostly, like, there's some developer liberty. Yeah, I'll talk about that afterwards. But yeah, so an app will create named folders in app data local and app data roaming. So if you look like Spotify, we'll have a folder in roaming and in local, right? And then based on whatever the developer choice is, in one of those folders, there'll be two files, kind of. One is a state file, which has some DP API encrypted data in there. And one is a cookie store, which is a SQLite database, which has cookie information for those authenticated sessions that those apps use. Like, Spotify will not ask you for your creds when you open it the second time. It's because it's loading those session tokens from that SQLite database, right? And so those session cookies are encrypted, and you have the state file which you use DPAPI to decrypt, and then you can read the cookies, essentially. I say that this is how it works mostly because there are some, again, some liberty, like for example, GitHub Desktop uses the Windows Credential Manager to store its authentication data. So developers can choose to do something different, but this is mostly how that works. Yeah, so I wrote a small tool. Like Electrolyte because if you see here at the bottom of the slide, like if you've done red team work and you've stolen like session data from browsers or cookies or passwords or something like that, you've probably used Sharp Chrome to do that in the past. And this is really similar because Electron is based on Chrome, right? So it's the same thing. The issue is that in Sharp Chrome there were some flags missing to let me easily point Sharp Chrome to the state file and the cookie database. So I ripped a bunch of code out of Sharp Chrome and put it like into Electrolyte. And so you just point it at these two files and it will decrypt it for you and give you back the cookies, right? And so I have a demo of this. Okay, so here I'm logged into Slack. Let me pause it right there. So I created like a Slack workspace just for this con to do the demos. And I don't know how readable the text is, but you get like I'm pointing Electrolyte like at the cookie store and at the state file for Slack, and then when I run it, it decrypts those cookies from the SQLite database, and then I get them, in plain text, right? Okay, I'm highlighting things apparently. That's what's going on. Yeah. So I launch here like a VM in Hyper-V so that you can see that in this VM, I don't have any authentication data for Slack. I should pull that up here. Yeah, you can see like I'm not logged in. I refresh the page, right? But then I can just edit the cookies for this domain. So I'll add just the one cookie. There's one called D, which has the main authentication token for Slack. So I just add that one in that I decrypted there. And then I tick some boxes. That's my job. Right, and then when we refresh, we're actually authenticated as the user in the VM. And we have access to that same workspace as on the base operating system. Yeah, you see, like we're logged in, like we're in the web app version of that workspace, and we can troll the user, right, or whatever. So I think like if you're on a red team engagement, probably this is how you would use this most likely. Like you extract the web session cookie, and then what you could do is, for example, inject a beacon into Slack, and then open like socks, so that on your attacker machine you could then proxy through the Slack process on the victim's host, and then there would just be Slack traffic coming from the Slack app, and it would look fairly normal, I would say. Not totally normal, but fairly normal. Probably normal enough that people wouldn't notice. Yeah, so it's kind of yikes. It's kind of yikes. I think the big thing is like when we do red team engagements, we take a lot of advantage of browser data, but we don't always realize, I think, that these Electron apps are just browsers as well. So you can loot them in the same way that you loot the browsers, right? So this looks familiar, right? Like what we've been doing. Like I said, this is kind of like using Sharp Chrome. I just made some minor adjustments to make it more convenient, like with Electrolyte. The one thing I want to mention here is that if you have DA on a domain, you can get the domain DPAPI backup key, and then you can dump these databases remotely. You don't actually need to pop that box to get the cookie data. You can do it all remotely. And I added some links here of some stuff you can review to get more background information. Cool. Yeah, I wanted to just talk a little bit about this. Like I think on the internet, right? There are like 3 kinds of people doing things. There's like red team, who is doing like authorized work for their clients. There's crime, who are stealing your bitcoins probably or something like that. And then there's like whatever intel services collecting for whatever reason. And I think these 3 groups are doing some things. They have overlaps, right? Like I imagine all of them probably want to steal your browser session data, right? But I think there are also differences between those. Like WhatsApp is a good example. Like if I have WhatsApp on my desktop, probably, no, or let's say somebody I'm targeting has WhatsApp on their desktop. Like I don't care that they have some private communications which they're sharing, right? But probably Intel might want to look at those private communications. So I think one thing here is that we're looking at this from like a kind of corporate perspective, but this is also affecting people, private people, right? Like another example would be Electron Bitcoin wallets, and these are just things people need to be aware of because these issues exist not just in corporate testing, but also in private people's lives, essentially. Now we understand how we can kind of extract this session data from many Electron applications. I decided to focus on Slack to do a kind of test case to limit test, like what can we do if we wanted to take this as far as we could. And then like, why did I pick Slack? It's just for some simple reasons. Like Slack is common, not just for private, but corporate use. In fact, at IBM, we use Slack, and I did some extensive testing on that. Slack has good API documentation, so that helps. That helps because we don't have to intercept requests and try to understand what the API methods are. They document them for us, so that's very helpful. And then I think chat apps specifically are probably underused during red team engagements because you'll know that like at your companies internally, people are sharing things they probably shouldn't all the time, or hey, here's a file, let me share it to you through this Slack app, or things like that, or talking about sensitive projects, right? So there's a lot of data that can be mined from these apps. And then finally, I thought there was an interesting case with Electronic Arts, who were popped or compromised, yes, last year. Some people bought like a stolen Slack cookie from the underground or wherever that is. And they did essentially what I did in the demo, right? They put the cookie in the browser and they authenticated as the user onto EA Slack. And then they did some social engineering to get one of the Slack IT people to set them up with VPN access into the network. So I think that demonstrates that there's a risk there for companies, right? And then, yeah, if we think about what the challenges are doing this kind of thing, we already crossed off the first one, so we can extract those web session cookies using DPAPI. That's not a problem anymore. So the only 2 things that remain are just some recon stuff, right? Like if I land on a user's machine, I need to understand workspaces they have access to, some very practical questions. And something else which is not apparent is that you don't only need this web session cookie, but each of the workspaces that the user has also has a kind of API token which you need to be able to extract. So those are the 2 remaining issues. So the first one, scoping user access, is very easy. There's actually a JSON file in app data roaming Slack storage. And this JSON file is like root state JSON, which contains a JSON blob, as you can imagine from its name. And that has some good data in there, like all the workspaces that user is authenticated for in the app on their machine. It has a description of those workspaces. It also has like user IDs and stuff like that. And anytime you download a file in Slack from any workspace, that JSON file will be updated, and there will be like a lot of metadata about that file, like what the permalink is for the file, who uploaded the file, when did you download it, what was the local path and the name of that file. And so that can be useful. Like let's say that you compromise a user in some sensitive business unit, you can look at all of their Slack downloads and maybe get some documents and stuff. So I think, yeah, we have an example of that as well. Yeah, so this is running Statikk Shiv like on my machine at home, and so you can see I'm a degenerate, like I'm in 50 Slack groups or whatever. I don't know. It's a nightmare. But yeah, so it doesn't, like in the test environment, I only have one workspace, but all of this works no matter how many Slack workspaces you're in, right? So I just wanted to show that, and then I think we have a demo here. Yeah, so here I just run --config. You can see it pulls up. I'm in this Wild West Hacking Fest San Diego workspace, and I did it like a test download. So you can see that it recovered one download by the user, and yeah, you can see the permalink to the file, which we can access. You can also see yeah, what the workspace is. So if a user has multiple workspaces, you can see all of that. You can see like when it was downloaded, what the file name was, and everything like that. So here in the Hyper-V VM, we're still logged in. And so I just want to show you, if I paste the permalink, then we can just download this file, right? I think I called it like, yeah, secret key.txt, but you get the idea. Like once you have access, this level of access, you are the user, you can grab all those files, right? Still, we're not talking to Slack's API. We're only doing this web stuff, right? But what we really want is to interface with Slack's API. And so, like I mentioned, each workspace has like a Slack token that we need to find. And it's a bit convoluted to do that, but we have all the information that we need. So from the root state JSON file, we can extract the workspaces as we saw, right? And so we have these workspaces in the red box here. And then from the state file and the cookie store, we can make GET requests, you know, normal GET requests to those workspaces. And so I think what I do is I make a GET request to one of the profile pages of some specific page on that workspace. And then in the response for that request, I get the token for that workspace for the API. And so it's just a bit convoluted, but once you know how to do it, it's not that difficult. And so we can see, again, the example here on my base machine where I just get API tokens for all of the workspaces that I'm authenticated to. And then we have a demo of this as well. Oh yeah, let me just, yeah, so you can see like here I have like a parameter I'm calling XOXS. That's because Slack, for some peculiar reason, changes the name of these cookies. So whenever I wrote this, the cookie was XOXS, but now it's XOXC or whatever. Yeah, I just wrote a regex, right, to get the cookie. So yeah, so I have this workspace for Wild West Hacking Fest San Diego, and I got the token. And then we can test the token because Slack has like, it allows you to test API methods on their website. And so this one, auth.test, we can use that to verify that this token is valid. We just paste the token in there, and when we test this method, we get back this data, right? Like it says, okay, is true. It tells you what the workspace is, what the user is that this token belongs to, etc., etc. Just want to talk a little bit about this before we go ahead. Slack session theft and history, right? My book is coming out soon. So initially I wrote the proof of concept for this in November 2020. So this is quite some time ago already. I have like a tweet with some nonsense, but you don't need to look at that. But just the point I want to make is that things change a lot over time. And so we saw that this local cookie store, the SQLite cookie store, is using DPAPI now to encrypt cookies, but that wasn't the case. In November 2020, those cookies were there in clear text. And so I think what happened there is like improvements in Chrome security made their way down to Electron eventually, because there's some lag time there, right? And then developers started implementing those methods to make their session data more secure. That's just like an example. The other thing is, like, we talked a little bit about that we need this web session cookie, but we also need a token for the API for each of the workspaces. And it used to be that you didn't need that web session cookie. You could just use the token, and that was fine. So there are like architectural changes that happen over a period, especially if you're looking since November 2020, right? And a lot of API documentation changes as well. So I think it's not just you write a toolkit, but you have to expect to maintain that toolkit. Otherwise, it stops working. It's not working. You have to expect to do the work. Cool. Boom, boom. Easy. Yeah, so then we have everything we need to do API automation. And I have this line here, right? Like, anything you can do, I can do better. This is a great song, by the way. You should check that out. But I think it's very accurate, because we can do anything the user can do. But the user is, when the user uses the desktop app or the mobile app, they are following some kind of UI experience. So they can do only things that the UI lets them do. But because we are talking to the API, we can do things sometimes that a user is not able to do directly, because it's part of some workflow or something like that. So I think while it's a lot of work to implement all the methods, we actually can do anything the user can do, but better, right? And just these are just some examples. We can get channel information, can do fuzzy search for keywords, get user details, read conversations, and send messages, right? Of course, these are things the user can do in the app as well, but there are things that they cannot that we can. One other thing about this is, like, when I say conversations, this is the term that Slack uses, but they mean everything basically, like channels, or IMs is also a kind of conversation between two people. And if you start a conversation with more than two people, they call it an MPIM, right? Like a multi-person IM or something like that. Yeah, that's it basically. And then you can use this link on the slide to look at their API documentation. So the first thing I want to check out, or like Recce, the battlefield. I think this is a Britishism. Okay, you would say in America, you would say recon the battlefield. Okay, just so you understand. So we do some information gathering with conversation list. We can get a list of all the conversations the user has access to. And something I should explain about this is that, let's say that an organization has 1,000 Slack channels. A user may have access to, let's say, 800 of those Slack channels, but they may only be in 10 Slack channels. The thing to understand here is that the API doesn't care if you are part of a channel or not, so long as your identity has access to those channels. So you can read channels that you're not a part, that the user hasn't joined, and things like, you can send messages that in channels the user hasn't joined, all those things. Yeah, so conversation list, and you can also use users info to get more details about a user account, some details which may be interesting for during the red team engagement. Yeah, so here I just pre-generated the token, but we've seen that we can do that, right? So I do a token, pass in the API token, and then I do -- conversations, and here I split it out in Statikk Shiv, so that conversations give you only channel information, and then I have another flag IM to give you IMs. So here you can see that, like, the channels in this workspace I created. Now here there are a limited number of them, but for example, at my company, there's like, I don't know, 50K channels. I don't know. So I've stress tested this. Yeah. You can see here if I go back, and highlight, you can see that, for example, this channel tech stuff, my user is not joined to this channel, but it doesn't matter. Like I said, you can poll all that data as you wish. Okay, and then we just do the same thing for IMs, and so we get the IMs. You can see there's an IM with a user called Avalon, another one with a user called Beef, and then Slackbot. So Slackbot is also a proper conversation in terms of API backend, right? And then, like I said, we can get user information. So if we copy that user ID and paste it here, you can see that we get more details about this user, like whatever their user ID is, their real name, like whatever their time zone, their title, like tech person at the place, right? And their number, email address, all of that stuff. So that can be useful when you're doing like recon on users on a network, right? And then, yeah, I think I'm just doing the same thing here. Cool, cool. Now, we don't only want to do some information gathering, right? Like we want to take our payment in secrets when we're looking at this. Like I said, that a lot of times users will share things maybe they're not supposed to, or they think it's fine to share it, or let's say some sensitive business unit, they talk about the product they're working on inside the company in their Slack channels. Makes sense. And as red team operators, we may want to read what they're talking about in those channels that may be useful to achieve our objectives. So I think the two main endpoints here are search all, which lets you do like fuzzy searching of keywords. So you can give it like 5 or 10 keywords, and it does some matching based on which messages match the best with all of your keywords. And so it's pretty good at searching. It's pretty good at searching. And then, of course, let's say that you find a message in a channel, like tech stuff, and then you want to be able to read, okay, I saw this message which looks interesting, but I want to read like 10 messages before that and 10 messages after that. You can do all of that. So that's the other part of this, where you pick then a conversation and you start reading it. Like you can pull the data more or less like the user sees it in the app. So here I do like search, and I search for the keyword secret. And in this case, I add the limit flag. All the requests have limit flags, but I'm just demoing it here. And so you can see we return one result where this user is saying like, definitely, but we have to keep the secret in this channel, right? Okay, whatever. So you can see the channel name, secret stuff. You can see the user that posted the message, at what time they posted it. You get a permalink to that conversation. And then here, like all I did was change the limit from 1 to 2 to show that you can pull back more matches. Like you don't have to just like, you can pull back 10K matches if you wanted to. You can do all of that. Yeah, so this other user is saying, hey, do you want to know a secret or whatever? I'm not sure what I'm showing here, so we'll find out together. Oh, yeah, I understand, yeah. So in Slack messages, like when you pull the data from the API, it doesn't do automatic conversion from user ID to their like proper name. So sometimes in messages, you'll see like @ with some ID. And so what I'm doing here is just, I saw... Hello? Oh, okay, yeah. I saw this ID in this message, and then I look it up to find out what user is that and pull back their details, essentially. Okay, so like I think like we saw some messages maybe we want to find more context about, and then we can do that, right? Like here I do -- history, and I paste in the channel ID, and then again, I think I'm demoing like I can do limit and pull back one result from that channel. So you can see like the last message was from Avalon, and he's using Giphy to post a meme. So this was very important to me that I had support for memes in Statikk Shiv. So if we take that URL, like we can actually see like what the meme was, right? If we wanted to. So it's the Picard facepalm meme. Yeah. But yeah, so maybe we want more details about what that conversation was like. And so we just add some more limit onto that. I just picked 6 here. And basically you get the conversation exactly as it appears to the user in the channel, right? You see there's the Picard facepalm. And yeah, if I just pause it there, like you can see these are exactly the messages that the user sees. And you even have support, like if you see the second message, like users posting reactions to the message, right? Like rolling, laughing, or whatever it is. So you can get pretty good like representation of what the user sees. So it lets you explore these channels where you might have sensitive data that you want to look at. Okay, cool, cool. Anything else here? No, I don't think so. But one thing I want to say is like here, I'm pulling history from a channel and I'm just pulling the latest messages. But let's say that you do a search for secret and you found a message like from 3 weeks ago. What you can do with the history command also is specify a timestamp. And then you can say, show me messages around this timestamp. And you can say like limit, let's say 10, and it will pull 10 messages before and 10 messages after that timestamp. So you can read historical conversations as well, but I'm not demoing that. Is the, okay, yeah, I think the mic pops out sometimes. Yeah, and so the final thing is, cut the mic. Test. Okay, yeah, perfect. Okay, perfect. Wow, that's louder. Boom. So the last thing is like selling the dream, right? Like we've looked for information, or we've done reconnaissance, we've extracted potentially valuable information from the chats, and then the last thing is like maybe we want to do some social engineering, right? We want to sell some poor soul a dream that they're going to buy and regret later. And so we can do the 2 main endpoints for this are like chat post message. So we can send a chat message like any other user, either in a channel or in an IM or MPIM. Again, Slack doesn't make a distinction. For Slack, it's all conversations. So we can do that, and we can also post messages with files that we attach, and for that we use the files.upload method, and it's basically like the same thing. So we have the demo as well. So I have this chat with Avalon or whatever, and I just do like post. And I looked up the conversation ID for this IM, so I don't show it, but I looked it up beforehand. And then I just post a message like, whatever. Sucks to be you, download my tool or whatever. I forget what I type here, actually. Oh, yeah. Yeah, I told him, like, I found this really cool piece of software. And, you know, when I send it, you can see like in the app that the message shows up as the user, right? Nothing too special. Yeah, and then I send them a follow-up message like, hey, I'll give you a link to this really cool piece of software that you can totally run. In this case, I attach a file just for this example, like it's just an image, right? Yeah, you get the idea. Like I could send him whatever I wanted, right? Like in this case, you know, trust me, I'm a dolphin. This is totally fine. Right. right? I don't know why let me just fast forward this. Yeah, anyway, sometimes you can't trust dolphins. I think that's the that's the main takeaway. But yeah, you can understand that because we can post messages and we can post messages with attachments, that we can do this kind of thing like we saw with the EA compromise, right? Like you can do social engineering over Slack in this instance. Either convincing them to do something or giving them some kind of file, and they probably think it's fine because it's coming from their internal chat application, right? Something like that. Oh, yeah. Okay. This is really good, okay? I found this quite interesting anyway. So when I was looking at file uploads, I noticed that you can force a file upload and specify an invalid channel. And what happens is the file gets pushed to Slack servers, but it doesn't appear in the Slack app. You still get a file reference back because something I didn't show is that you can obviously delete messages, not just post them, but you can delete them and delete files. But so you can upload a file to Slack servers. It doesn't appear in the app. You still get the file reference. And so somebody else can access that file, but there's no way to see that it exists in the app. It only exists on Slack servers. And there's also an endpoint in the API where you can search for file names with patterns. So I think this is an ideal C2 mechanism because you could like compress and encrypt some binary data. You push it to Slack servers, you name your file with some specific pattern, and then whatever the C2 server can search for files matching a pattern and download your data, decompress, decrypt it, do something, and send data back and forth. And there would be no way for the user to ever see that they uploaded a file. It wouldn't show up anywhere. You'd have to have the link to that file to actually be able to see it on Slack servers, right? So this is a perfect C2 mechanism, I think. Right. So yeah, send help. I think, when an attacker pops a user's box, like they also gain control over all the things that are on the user's box. I think for some things we understand that, like for example, a Chrome session data or something like that. Or we understand that if we compromise a user's machine and their AD joined, in a sense, we've breached that corporate network, right? So it's not just those things that we typically associate. It's also things like Electron apps. And then in this case, like Slack is a very prescient example because like it may be used heavily in the corporate environment. I think the thing here for Electron apps in general, not just Slack, is to do proper collection of logs, right? Slack actually has pretty good logs, but I don't know that many companies are ingesting those logs and generating alerts based on those logs. Probably they are not. We should check that. We should check that at IBM, actually. We should figure that out. And so there are things you can do, like you can look for anomalous authentication events. Anytime a new device authenticates to Slack, you'll get events for that. So if a user has never used Safari to authenticate to Slack, like you'll get an event for that kind of stuff. Same for unique IPs. If an IP that's never authenticated, you'll get an event for that. And so I think we should ingest those events and just write some rules to alert on those. The other thing is that these applications, like I mentioned, maintain authentication state, and where possible, we should just try to reduce that state obviously we can't ask the user to type in their password every hour because they'll go mental. But just reduce it as much as the business lets you, so that if a session is compromised, like this stolen cookie with EA, then that access window is as small as it could be, right? And you have some links there to Slack's official documentation on how you can do the logging and ingest those logs. All right, that's it. Okay, cool. Thank you. Are there any questions about this? No? Okay, silence. Any questions on no? Okay. Excellent. Okay, awesome. Then I'll oh yeah. Hit me up. Yeah, you can delete messages. Yeah. Oh, okay. This is something I should say. Like, let's say that in the app you have a notification, like you have an unread alert in a channel. You know, if you click in the app, that notification disappears, right? But when you search with the API and you read that message, that notification doesn't change for the user in the app. So it's a stealthy way to read their messages. Yeah. And you can delete messages. Yeah. All you need is the ID for that message, and you can post like delete. Yeah. Like I said, they say that they moved off of like Electron, but I think because Edge is Chromium based now, you can do the same thing. So you can dump their cookies. I tried it on my machine, yeah, but I didn't look at automating any of this stuff like I did with Slack. Okay, follow-up question. Go ahead. No, I think probably there is. Because when we authenticate as the user on Slack, we can use any services that are integrated into Slack. So I can post memes, but this is a benign example, but right? But let's say Jenkins is integrated for example, then you could make requests to like a Jenkins bot to kick off some task, or so I imagine on Teams you could access their SharePoint and things like that. Let's get on that. Let's do that. Yeah. Okay. Any other questions? No? Cool. Then I just want to say, yeah, reach out to IBM or just come have a chat. We'll be around. Actually, a lot of our team is here, right? If not, you can always reach me on Twitter. I also put my boss's Twitter there, and you can message him, and it's not my fault. So yeah, so I'll let you take that for what it is. Okay, that's all.
All right, thanks, Ruben. Nice talk.